Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aimakin Beraskin, 33DPC 24F1019. Today I want to present about jetau. But did you know the jetau process is so precision that it can be used to weld material in space. In 1969, Russian cosmonaut about Soyuz 6 conducted experiment and successfully weld metal in the vacuum space using electron beam, plasma arc and arc welding technique. They report that these welds were just as strong as performed on Earth. This demonstrates the versatility and control offered by jetau. Firstly, gas tungsten arc welding jetau technique, function, defect and prevention. Precision, versatility and control in welding is very important for every welder to get a perfect workpiece. Cover fundamental to advanced application, comparison with conventional method, rough of quality in weld quality. Principle of gas tungsten arc welding. Arc generation, electric arc between tungsten electrode and workpiece. The temperature also can reach 20,000 Celsius. Shielding gas use argon gas or helium to prevent the contamination. Heat concentration, pressure heat for control fusion. Filler addition is optional. Manual filler metal to tap up the hole at the workpiece. Why use jetau? Non-consumable tungsten electrode exceptional control. That is very easy to use, and it also have a high quality weld, and it's very ideal to clean the workplace. Okay, let's go to the third slide. Jetau versus conventional welding or SMAW. Feature electrode in jetau is non-melting tungsten, and for SMAW in consumable melt into weld. Filler metal add separately, and SMAW is integrated in electrode. Jetau shielding use argon and helium gas. For SMAW is use a flat coating. Precision, jetau is very high, like a fine paintbrush. SMAW is lower for forgiving, and the jetau has a slower speed. For SMAW is faster, and deposition. Clip up for jetau is minimal, and for SMAW is adhesive slags removal. Jetau excel in precision, and for SMAW prioritize the speed. Okay. Fourthly, polarity in jetau. 3 polarity option. First, decent, Defect, AC. Defect is for direct current electrode negative. DCEP for direct current electrode positive. AC is for alternative current. First, decent. 70% heat direct to workpiece to deep narrow weld. Best for steel, stainless steel, titanium. Second, Defect. 70% heat at electrode, oxide cleaning action, rarely used due to the electrode overheating. Thirdly, AC. Combine decent and Defect, ideal for aluminium, magnesium to oxide removal. Polarity affects penetration, weld profile and material compatibility.
Good morning, everyone. Did you know that gas tungsten arc welding or JITAO is the only welding process capable of producing joint so clean and precision? There's it used to build NASA, spacecraft, and military fighter jet. Because of its unmatched precision, JITAO is trusted where failure is not option. I'm Muhammad Iqbal bin Halim, register number 33DPC24 F1020. And today I will present about JITAO equipment, its advantage and its disadvantage. Let's first look at the essential equipment required for JITAO. First, power source. This provides a very precision electric current adjustable from 5 to 300 ampere. It allows welder to perfectly match the heat input to the material thickness. Furthermore, gas delivery system supply insert shielding gas like argon or helium. This gas protect the molten weld pool from air contamination, preventing defect like porosity. Besides that, Jitao torch, the torch hold the non-consumable tungsten electrode and directly shielding depending on the job, essentially torch water cooled. Additionally, welders often use a foot pedal to control the current dynamically during welding, similar to how a car accelerator works, providing fine, real-time control over heat input. Now, we go through the slide next. Advantage of Jitao welding. What is Jitao highly favored in high precision industry? Firstly, superior precision and control. In Jitao, heat and failure material are controlled separately, allowing welder to create extremely fine and detailing weld. Other than that, exceptionally well cleaners. Since no flood is used and shielding gas fully protect the well, the result is a very clean well with little to no sputter or slag. Moreover, material versatility. Jitao can weld a wide range of material from carbon steel, aluminum, magnesium to exotic alloy like titanium. And lastly, stronger mechanicals. Because of the heat effectly zone is smaller, the base material retain more of its original strength with less distortion. Fun fact. Jita was first introduced during World War II to weld lightweight magnesium part for aircraft, and today is the remain vital for aerospace, semiconductor, and food grade manufacturing industry. Now we go through the next slide is disadvantage of Jita welding. However, even with all its strength, Jita does have some limitation. First, slower process. GTAW is estimated to be 4 to 5 times slower compared to methods like small or MIG welding. Secondly, high skill requirement. Welder must coordinate the torch, filler rod, and foot pedal simultaneously, require excellent hand control and practice. Next, high equipment cost. Digital machine and accessory are more expensive compared to conventional welding setup. Last but not least, environmental sensitivity. Shielding gas coverage can be easily disrupted by wind or draft, making digital less ideal for outdoor welding without proper protection. In short, digital is the best choice when weld quality and precision are the highly priorities, but it may not be practical for high speed or large scale producing. In conclusion, Jitao is deliver the cleanest, most precision well available today, but it demands skill, patience, and the right equipment. And now we go to Adam.
Good morning, everyone. Thank you for Iqbal for the group presentation. Right now, I will present about the common welding defect in the GTAW. First, porosity. Gas bubble trapped in the well result from the contaminated surface in the insufficient shedding gas or the improper filter handling. Second is cracking, furniture that from during cooling, hot crack, or later due to the hydrogen contamination or the tension cool crack. Third is tungsten inclusion. Electrode framing in the well causes electrode well put the contact or the excessive current causing electrode deterioration. Third is the undercut, a groove along the well edge that reduces base metal tightness, cracking the structure weak point. For the second section, I will tell about the defect prevention in the GTAW welding. Starting with defect prevention, the first step is the pre-weld preparation. We need to clear base material and the filter rod thoroughly using a solvent, wire brushing, or chemical cleaner. This prevents contamination that will weaken the wheel. Next is the shedding gas management. Adequate gas flow is the structure to protect the well from the atmospheric gas. Choosing the right gas type, cup size, and preventing draft all help maintain a stable well environment. Then we have the parameter optimization, proper setting current, polarity, gas flow, travel speed, and the right electrode type are critical for consistent quality. Finally, collect the technique application. This includes the maintaining consistent outlet, proper the electrode angle, smooth filter and rod feeding, and the steady travel speed. For the third section, distinction in the welding cost and type. Now, about the welding distortion. Distortion mainly happen because of thermal expansion and contraction. Metal expand when the heat and the screed well cool, cause a warping if not controlled. They have a four type: thermal expansion and a contraction cause general warping, a longitudinal stickage along the well line, transverse sinkage across the well, across detection, creating a V shape due to the universal heat distribution. For the, for the last section is a minimizing welding distortion, a practical approach. To control distortion, we apply the five main strategies. First strategy, planning. Plan the weld sequence and the design carefully. Second, mechanical control. Secure part properly and the fixture. Third is a thermal management. Balance the temperature through preheating and the and the control the cooling. The fourth is the welding technique. Minimize a heat input and the use method like the backstab technique. And finally, post-weld treatment. Apply the stress release to collect and reduce residual distortion. Okay, that's all from me. Continue with the Daniel Alif.
My name is Muhammad Daniel Alif, matrix number 33 DC 24F 1016. And today we'll be giving a brief overview of digital welding, also known as gas tungsten arc welding or TIG welding. This welding technique is known for its precision and cleanliness, which makes it a popular choice in industries where quality cannot be compromised, such as aerospace, pharmaceuticals, semiconductor manufacturing. In this presentation, I'll explain the key welding parameters, the standard that ensures quality, and how the process is evolving with new technologies.
Okay.
Let's go up. Let's start with the welding parameters. In digital welding, several variables must be carefully controlled to ensure a successful weld. First, current typically ranges from 5 to 300 amps, and it directly controls how deep the weld penetrates into the material. Voltage usually falls between 10 and 20 volts and affect the width of the weld bed. Travel speed, which can range from 3 to 20 inches per minute, which influences both how much heat is applied and how quickly the weld costs. Digital welding is guided by well-established standards and documentation to ensure safety and consistency. 5 key organizations set the rules for welding codes: AWS, ASME, API, ISO, and EN. These bodies define the essential requirements for reliable and safe welding practices. ASME BPVC 2019. Every welding procedure specification, or WPS, includes 9 critical variables that welders must follow. These include things like current, voltage, travel speed, shielding gas, and among others. AWS B2.1/B2.1M 2020. There are also 3 important documents in welding for quality control. The Procedure Qualification Records, PQR, which confirms that the welding method works, the WPS, which provides the detailed instructions, and the Welder Qualification Test, which checks the welder skills. Additionally, all critical welds must be inspected 100%. This includes visual inspections and, when necessary, more advanced testing methods to confirm the weld strength and safety. ISO 17637-2016. This procedure helps to ensure that every weld must meet strict quality standards, regardless of where or by whom it is performed. JITA welding is essential in industries where precision and durability are absolutely necessary. It is commonly used to build jet engine components, medical tools, semiconductors, and parts for the automotive industries. As technology evolves, so does the JITA process. Today, we see the introductions of adaptive power sources that automatically adjust the welding parameters during operations. Real-time monitoring systems are also being used to instantly detect issues during the weld. Additionally, hybrid techniques that combine JITA with lasers or plasma welding are emerging, helping to improve speed and efficiency while maintaining the signature quality of JITA. TWLILTP 2023. These innovations are making JITA welding more efficient and dependable for the future. To summarize, JITA welding is one of the most precise and reliable welding methods available today, but carefully managing the key parameters, following internationally organized standards, and embracing new technology developments, we can continue to produce high-quality welds for even more critical applications. That is all from me. Thank you for your